ተማሪዎች እንዴት ናችሁ? እንዴት ነው? ቤት ተቀምጣችሁ ያነበባችሁ ነው አይደል? ስለዚህ ያው ፕሮግራሞቹን እየተከታተላችሁ እንደሆነ ምንም አይነት ጥርጥር የለንም። ስለዚህ በደንብ አድርጋችሁ መከታተል ይኖርባችኋል። ስለዚህ ዛሬ የመጨረሻ ዩኒት የሆነውን ዩኒት 6 እናያለን ማለት ነው። ስሜ ብሩክ አለሙ ይባላል። ዝግጁ ናችሁ? እንቀጥል። Okay, this is grade 11. The last chapter is carboxylic acid, esters, fats and oils. 3 subtopic. One is carboxylic acid, the other one is esters, and finally discuss about fats and oils. This is under unit 6, grade 11, the last topic. The first introduction part is organic chemistry. You know chemistry different major parts. One is organic chemistry. Organic chemistry is a field of chemistry which deals with hydrocarbons and oxygen containing hydrocarbons. Hydrocarbon means hydro means hydrogen, carbons means carbon. Therefore this compound containing two elements, especially hydrogen and carbon, is known as hydrocarbon, and oxygen containing hydrocarbons. By the way, oxygen containing hydrocarbon means like alcohol, the general formula ROH, aldehyde RCOH, like ketone RCO. You know what I mean by alcohol means, aldehyde means, again ketone in grade 10. Therefore ROH alcohol, RCOH aldehyde, RCOR, ketone, again RCOOH. This is a general formula for carboxylic acid. Again RCOOR is known as ester. All these compounds are contain carbon, oxygen and hydrogen. This types of compound is oxygen containing hydrocarbons. Therefore organic chemistry is a field of chemistry that deals with hydrocarbons and oxygen containing hydrocarbons. These oxygen containing hydrocarbons like alcohols, aldehydes, ketones, ester, carboxylic acid, ether, and so on is under organic chemistry. Now the first point is carboxylic acids. Carboxylic acids are organic compounds that contains at least one carboxyl group in their structure. Therefore, any carboxylic acid must be contains the functional groups of COOH. This is a carboxylic acid. It is organic compounds that contain at least one carboxyl group in their structure, is known as carboxylic acid. The functional groups of carboxylic acid is called the carboxyl group. This is COOH or COOH. CO2 means COOH. Therefore, this is COOH. COOH is the functional groups of carboxylic acid. Therefore, any carboxylic acid must be contains a COOH functional groups. This COOH are known as CO2H, or sometimes represented by this one, C double bond OOH. This is what? This is the functional groups of carboxylic acid. This group is what? One CO, the other one OH. CO carbonyl, OH hydroxyl, collectively known as carboxyl group. Therefore, any carboxylic acid must be contains COOH group. This group is called what? A carboxyl group. Therefore, what is the functional groups of carboxylic acid? COOH group. The first one is saturated monocarboxylic acid. You know saturated? Carbon-carbon single bonds. Monocarboxylic acid. Monocarboxylic acid means it contains only one COOH group. Look, this is the general formula for a saturated monocarboxylic acid. Saturated means carbon-carbon single bond. This is COOH. How many COH students? One COH. One COH is what? One carboxyl group. In structure is known as, it is monocarboxylic acid. Now, in the case of monocarboxylic acid, or in the case of carboxylic acid, are three possibility. One, R may be hydrogen. Hydrogen is possible. Or R may be alkyl. Alkyl is possible. Alkyl means CH3 methyl, CH3, CH2 ethyl, CH3, CH2, CH2 propyl, and so on. Therefore, these are hydrogen is possible. These are alkyl is possible. Again, are possible aryl group. Aryl means aromatic compounds like this phenyl group. This is aryl group attached with organic compounds. This is phenyl group. Therefore, this is one of the parts of benzene. Removing of 1H is aryl group. Therefore, R hydrogen is possible, R alkyl is possible, R aryl is possible. Three possibility. Therefore, this R is possible with hydrogen or alkyl or aryl groups. The first three saturated monocarboxylic acids are, look, it contains COOH. What about this one? COOH. What about this one? COOH. How many COH? Only one COH group in one structure, in one molecule. But in this case, this is R. In this case, this is R. Again, in this case, this is R group. Now, this R is hydrogen. This R is CH3. This R is CH3, CH2. The first one, A, indicates R is hydrogen. The name is known as methanoic acid. Methanoic acid means a one carbon carboxylic acid known as methanoic acid. In the case of alkane, methane, a one carbon, two carbon, ethane, three carbon, propane, four carbon, butane, and so on. But in the case of carboxylic acid, methane converted into methanoic acid, ethane converted into ethanoic acid, and so on. Therefore, methanoic acid, ethanoic acid because of two carbon, propanoic acid because of 1, 2, 3 carbon. Therefore, ABC indicates the first three saturated monocarboxylic acid. Why saturated? Because carbon-carbon single bond. This is carbon-carbon single bond. The simplest aromatic carboxylic acid is benzoic acid or benzyl carboxylic acid. The simplest aromatic compound, this one. Look, this is benzyl ring attached with COOH. This is carboxylic acid, yes. Why? Because it contains COOH group. COOH is a carboxylic acid functional group. In this case, what is R? This is R. Therefore, R, hydrogen is possible. R, alkyl is possible. Like CH3, CH2, like phenyl group. Therefore, in the case of R, this is aryl group. Now, the name of this one is benzoic acid, common name. Or the IUPAC name of this one is benzyl carboxylic acid. Therefore, the simplest aromatic compound of carboxylic acid is called benzoic acid or benzyl carboxylic acid. Di and tri carboxylic acids. Di means it contains two COOH group in one structure. Tri means, or tricarboxylic acid means, three COOH group in one structure. Therefore, in one structure, it contains only one COOH group, this one, COOH group. Only one COH group present in the molecule is what? Monocarboxylic acids. It contains two COH group in one molecule or in one structure is dicarboxylic acid. It contains three COH group in one molecule or in one structure is tricarboxylic carboxylic acids. For example, look this one. This contains COOH group. How many COH group? One here, another COH group. Look this one. COOH, one. COOH, two. In how many molecules? In one molecule. Therefore, this is dicarboxylic acid. Similarly, COOH, COOH, two. COOH, COOH, another two. Therefore, A, B, and C indicates dicarboxylic acids. But in the case of the first one, in A, how many carbon? 2 carbon. The name is what? Ethane dioic acid. Look, ethane dioic acid. Ethane indicates the number of carbon. Dioic acid indicates the number of COH group. Similarly, 1, 2, 3. 3 carbon. 2 COH group is propane dioic acid. Look this one. How many carbon? 1, 2, 3, 4. 4 carbon alkyl, butane. But how many COH group? 2. Therefore, butane dioic acid. Butane dioic acid. Simply, dioic acid indicates the number of COH group, but butane indicates the number of carbon groups. The other one, the simplest aromatic dicarboxylic acid. The simplest aromatic monocarboxylic acid is benzoic acid. This is the simplest aromatic dicarboxylic acid, as known as phthalate acid. Look, this is benzyl group attached with COH. Therefore, COH in 1, 2 position. In the first carbon, COH, the second carbon again COH. Because of that, 1, 2, benzyl dicarboxylic acid, simply known as phthalate acid. Examples of tricarboxylic acid. Citric acid. Citric acid is a typical example of tricarboxylic acid. Therefore, this is citric acid. You know what I mean by citric acid? You know citric acid. Therefore, this citric acid contains 3 COH group. 3 COH group in one structure. Therefore, this is a good example for tricarboxylic acid. Citric acid is a good example for tricarboxylic acid. Nomenclature of carboxylic acid, which means naming of carboxylic acid. The first one is common name. Common names of carboxylic acid. Look the structure. HCOOH, CH3COOH, CH3CH2COOH, and so on. The common name of the first one, HCOH. The first monosaturated carboxylic acid is HCOH. The common name is known as formic acid. Formic acid. The second one is 2-carbon carboxylic acid. Monos carboxylic acid is acetic acid derived from vinegar. Formic acid derived from ant. The third one is CH3CH2COH. The common name is propionic acid. This one is the source derived from milk. Again, the fourth one, this one, CH3CH2CH2COH. Monocarboxylic acid. The common name is butyric acid, derived from butter. The fifth one, CH3CH2CH2CH2COH, valeric acid, derived from flour. And finally, the number of carbon is 6 with COH group is caproic acid with goat. Therefore, this is the common name of monocarboxylic acid. The first one is formic acid. The second one, acetic acid. The third one, propionic acid. The fourth one, butyric acid. The fifth one, valeric acid. The sixth one is caproic acid. This is common names of monosaturated carboxylic acids. The other one is branched chain. Branched chain, or known as substituents. Look this one. COOH, This is the functional groups of carboxylic acid. Therefore, COOH is a functional groups of carboxylic acid. Always numbering starts from the functional group, closest to the functional group. Therefore, this carbon is 1, 2, 3, 4, 5, and so on. This is what? In IUPAC system. In common name, by using of the second carbon, because in the first carbon there is no side chain. Already carbon is satisfies octet rule. Carbon already forms 4 bonds. 1, 2, 3, 4. 4 means 8. Therefore, always branch starts from the second position. The second is known as alpha. This is, by the way, common name. In IUPAC system, by using of numbering 1, 2, 3, and so on. In common name, by using of what? Alpha indicate the second position, beta the third position, gamma the fourth position, delta the fifth position, and so on. Therefore, alpha, beta, gamma, delta using in common system. But in the IUPAC, by using of simply numbering. Dicarboxylic acid. Common names of dicarboxylic acid. Look, this one, COOH, COOH. In the case of IUPAC name, how many carbon? 2 carbon, ethane dioic acid. In the case of IUPAC. In the case of common name is oxalic acid. This is 3 carbon, but COH, all are, by the way, dioic acid. The only difference is the number of carbon. Therefore, how many carbon? 1, 2, 3. IUPAC name, propane dioic acid. Common name, malonic acid. 4, 1, 2, 3, 4. Butane. The alkane name. The acid for 2COH group is butane dioic acid. But the common name of this one is succinic acid. And so on. Please, students, read from your textbooks. Aromatic carboxylic acids. Look at this one. This one is benzyl ring. This is COOH. Students, what is the name of this one? One, benzoic acid, the common name. The other one is what? Benzyl carboxylic acid. 2 names. One is common name. The other one is IUPAC name. This benzoic acid, is there any side chain? Is there any substituent? No. But one side chains are present, uses ortho or sometimes O. Meta, M, para, P can be used. Ortho, meta, and para can be used. Look, if the side chains are from this position, for example, like CH3, always this one is 1. COH is the first position. CH3 is 2. Numbering always starts from attached with COH group. Therefore, this one is 1. This is 2. Is there any side chain? Yes. Which one? CH3. In which position? In the second position. By the way, always in the second position is side chain known as ortho. Look, 1, 2. 1, 2 position is ortho. 1, 2, 3. 1, 3 is meta. 1, 2, 3, 4. Para. 1, 2 is 1, 2 is what? Ortho. 1, 3 meta or M. 1, 4 is what? Para. Therefore, this is 1. This is 2. Therefore, 2 in the second position is what? CH3 group. Because of this CH3 group, simply use ortho or simply O. Ortho what? Methyl. Orthomethyl benzoic acid. Benzoic acid. Therefore, the common name of this structure is orthomethyl benzoic acid. What indicates ortho? In the second position is CH3. Therefore, orthomethyl benzoic acid. If this CH3, let's change it into this one. Let's take this one is COH, CH3 from this position. In this case, 1, 2, 3. Is it ortho? No. Is it para? No. This is meta because the third position. 1, 2, 3. Meta. Therefore, meta, simply M, meta, metamethyl benzoic acid. The second position, orthomethyl benzoic acid. The third, metamethyl benzoic acid. The fourth, para-methyl benzoic acid. This is simply aromatic carboxylic acid attached with different side chains. If this CH3, let's take change it into fluorine, fluoro, chlorine, chloro, bromine, bromo, and so on. Simply in aromatic carboxylic acid, in common name uses what? Ortho, meta, and para positions. IUPAC names of carboxylic acid. The first one is what? Common name. This is the IUPAC name. In the case of IUPAC name, look, monocarboxylic acids named as alkanoic acids. For example, alkane. Alkane. What is the ending letter of an alkane? E. This E. This E replaced by OIC acid. Which means what? The ending letter of an alkane E replaced by OIC acid is known as what? Alkanoic acid. That means what? Alkane, alkanoic acid. Alkane, alkanoic acid. Therefore, look this one. First, this is carboxylic acid. How many carbon? Only one carbon. One carbon alkane is what? Students, what is the one carbon alkane name? Methane. Methane is this one. ANE. Which one is replaced? This E replaced by OIC acid. Therefore, what is the name of this one? Methanoic acid. Therefore, this is methanoic acid. OIC acid, look, without OIC acid, methane. Already OIC acid replaced by E, methane. E removed, OIC replaced methanoic acid. 2 carbon, ethane. The acid name, ethanoic acid. Propane, propanoic acid. Butane, butanoic acid. Pentane, pentanoic acid. Decane, decanoic acid. The only difference is the ending letter of one alkane, E, replaced by OIC acid, is the name of monocarboxylic acids. The branched chain. The previous one is branched chain, common name. This one is branched chain in IUPAC names. In the case of IUPAC name, this carbon in the first position. 1, 2, 3, 4, 5. In common name. Alpha, the second, beta, gamma, delta, and so on. Look this one. Write the IUPAC name. In the case of IUPAC name, uses number. Write the IUPAC name for the following carboxylic acid. What is the IUPAC name of this one? What is the first rule? Select the longest continuous chain that contains COOH functional group. Therefore, what is the functional group COH? Therefore, select this one. Why select this one? Because this is the longest continuous chain that contains functional group. Next, start numbering. Numbering start from the nearest to the functional group. In which position? This position. Because already COH is this position. Therefore, 1, 2, 3, 4. Next, is there any side chain? Yes. In which position? In number 1, number 2, number 3, number 4, and so on. In number 3. This is CH3. In IUPAC system, CH3 present, the name is known as methyl. In which position? Third position. Therefore, 3-methyl. 3-methyl. How many carbon? 1, 2, 3, 4. Butanoic acid. 3-methyl butanoic acid. Why 3-methyl? Because in the third position is CH3. Therefore, 3-methyl, 1, 2, 3, 4 carbon, butane. The acid name, butanoic acid. 3-methyl butanoic acid. Look the other example. First select the longest chain. This is the longest chain. Numbering start from this position. 1, 2, 3, 4, 5. Is there any side chain? Yes. Bromine. Br, by the way, bromine. But in substituent or in side chain is what? Bromo. In which position? In fifth position. Therefore, 5 bromo. 5 bromo. Is there any another side chain? No. Therefore, what is the parent? 1, 2, 3, 4, 5. 5 is what? Pentane. With acid name, pentanoic acid. Pentanoic acid. Let's take another example. CH3, CH, CH, COOH. Let's take this one is Br. This one is CH3. In this case, first select the longest chain, this one. Next, giving number 1, 2, 3, 4. Is there any side chain? Yes. How many? 2 side chains. One is Br. Br is what? Bromo. The other one is CH3. Methyl. In this case, which one is alphabetically first? Bromo starts from B. Methyl starts from M. Which one is alphabetically first? B or M? B. Therefore, first write 2 bromo. Another side chain is 3 methyl. 1, 2, 3, 4 is butane. The acid name is butanoic acid. This is the IUPAC names of monosaturated carboxylic acids. See, dicarboxylic acid. Simply, in the case of dicarboxylic acid, simply uses how many carbon first? 1, 2, 3. 3 carbon is what? Propane. In the case of 1 COH group, simply E replaced by OIC acid. But in the case of 2 COH group is, simply writes the full name, propane. Finally, dioic acid and so on. Therefore, in dicarboxylic acid, namings of alkane, dioic acid. Look this one. 1, 2, 3, 4. 4 is what? Butane. Butane. And finally, dioic acid. Aromatic carboxylic acids. In the case of aromatic carboxylic acid, students, what is the name of common name of this one? Yes, this is benzoic acid. But the IUPAC name is benzyl carboxylic acid. In benzyl carboxylic acid, side chains are present, uses a number. For example, look at this one. Already COH group. Cl is here. CH3 is here. Now all weight, this is 1. 2 is next to COH group. This is 2, 3, 4. Now in the second position is chlorine. In the fourth position is methyl. Chlorine is what? Chloro. CH3 is what? Methyl. Chloro starts from C. Methyl starts from M. Which one is alphabetically first? Chloro, C. Therefore, 2 chloro, because in the second position. 4 methyl, benzyl carboxylic acid. Students, please write the IUPAC name of these structures. What is the name of this one? The first one. First, 1, 2, 3. In the third position is what? NO2. Therefore, 3 nitro. By the way, NO2 is nitrogen dioxide. But in common name or in IUPAC system, simply nitro. 3 nitro benzyl carboxylic acid. This is what? 1, 2. Therefore, 2 hydroxy benzyl carboxylic acid. OH is hydroxy. 2 hydroxy benzyl carboxylic acid. This one is 3 nitro benzyl carboxylic acids. Physical properties of carboxylic acid. The first one is states. What is the states of carboxylic acid? The lower aliphatic acids containing up to 9 carbon atoms are liquids, whereas the higher members are colorless, waxy solids. Benzoic acid and most of its derivatives it is a colorless solid. Therefore, the states of carboxylic acid, especially up to carbon number 9 it is liquids, and the higher members are colorless waxy solids. The second one is odor. The odors of lower aliphatic acids progress from sharp and irritating odor, not a good smell. It is unpleasant odor. Therefore, the highest acids have little odor. Why the highest acids are little odor? Because of their low volatility. By the way, the number of carbon it increases, volatility will be decreases. Boiling point. By the way, the boiling point of carboxylic acid greater than the other types of organic compounds, like alkane, alkene, alkyl, like alcohol, aldehydes, ester, and so on. This is why, because carboxylic acids it forms a dimer. Dimer means one carboxylic acid attached to another carboxylic acid, it produces two hydrogen bonding. Look this one. RCOOH. This is one carboxylic acid. Again this one, RCOOH. This is another carboxylic acid. This oxygen, the carbonyl group oxygen attached with the other hydroxyl of H, this is hydrogen bonding. Again, the carbonyl groups of another carboxylic acid O attached with the hydroxyl groups of H. This is hydrogen bonding, this one is hydrogen bonding. Therefore, carboxylic acid with carboxylic acid, it produces hydrogen bonding 2 times. Because of that, this one is a carboxylic acid dimer. Because of dimer formation, carboxylic acids higher boiling point than alcohols of comparable molecular masses. This is because of dimer formation. The fourth one is solubility. In the presence of water, carboxylic acids do not dimerize. That means carboxylic acid with water forms hydrogen bonding, but not a dimer. Carboxylic acid, 1 up to 4, methanoic acid, ethanoic acid, propanoic acid, and butanoic acid, 100% soluble in water. But the higher members of carboxylic acid will be insoluble, or solubility will be decreases. Therefore, the lower members of carboxylic acid soluble in water, the higher members of carboxylic acid, the solubility will be what? Decreases. Therefore, the carbon number increases, the solubility will be decreases. Simply, the lower members of carboxylic acid easily insoluble. The higher members of carboxylic acids are generally not soluble. This is the general structure, carboxylic acid with water interaction. This is chemical properties of carboxylic acids. The carboxylic acids show reaction due to xyl-chyl or aryl group and the carboxyl group. Reaction as an acid. Carboxylic acid is an acid. Look, RCOOH plus water. This is double arrow. This double arrow indicates all carboxylic acids are weak acids. Why weak acid? It dissociates slightly or partially. Therefore, carboxylic acids are weak acids. Why? Because it dissociates slightly. When a carboxylic acid reacts with water, it gives carboxylate ion and hydronium ion. Therefore, carboxylic acids it is an acid, but what types of acid? Weak acid. Why weak acid? It dissociates slightly or partially in water. Therefore, carboxylic acids are weak acids and it dissociates slightly. Therefore, all carboxylic acids are weak acid. Why? Because it dissociates slightly. This double arrow indicates carboxylic acids are a weak acid, and finally it produces carboxylate ion and hydronium ion. ተማሪዎች የዛሬው ትምህርታችን ይሄንን ይመስላል። ለቀጣይ ግን አንድ ሪዲንግ አሳይመንት ልሰጣችሁ ፈልጋለሁ። chemical properties of carboxylic acid and preparations of carboxylic acid አንብባችሁ እንድትጠብቁኝ እፈልጋለሁ ለሳምንት። ስለዚህ መጽሐፋችሁ ላይ ኬሚካል ፕሮፐርቲውን እና ፕሪፓሬሽን ኦፍ ካርቦክሲሊክ አሲድን በራሳችሁ አንብቡ። እኔ ቀጣይ አንድ ላይ አያይዘን እንቀጥላለን ማለት ነው። ዛሬ ስለተከታተላችሁኝ አመሰግናለሁ። ቴንክ ዩ